Industry Talks by ARC Advisory Group.
Hello, everybody. Welcome to ARC Industry Talks, the monthly podcast where we discuss the latest industry trends. My name is David Humphrey. I'm Research Director with ARC Advisory Group in Europe, and I'm here with our General Manager, Florian Güldner, to talk about the latest trends. Florian, here we are back in our cozy studio. You do this analysis of ArcWire, that's our monthly newsletter, and the topics that get the most hits every month.
Yeah.
You've done this recently. What was the results?
You mean the very complicated analysis that requires such a big spreadsheet, right?
Exactly.
Nothing. No.
Did you not have time, or what are you doing?
We had the time, but we didn't run the full analysis.
Okay. All right. Where have you been?
Well, at SPS in Namur, and frankly speaking, there was so much going on that we didn't need a spreadsheet. We were out in real life discussing to users and suppliers to see what's going on. So I thought we just discuss today about what we have experienced on both shows, and take it from there.
All right, let's do that. Nothing like getting out and actually talking to people in the industry to find out what's going on.
Yeah. So I actually want to start with you, David. So, and the SPS show, what is the pulse of the industry? How was SPS?
SPS is my favorite show. It stands for Smart Production Solutions, and it's a very discrete, focused show. It's only 3 days long. Takes place in November every year in Nuremberg. And I always wonder, can a trade show be a bellwether of the industry? Is it a fake mood? Is it realistic? And I find SPS to be pretty accurate. The mood I would say this year was subdued, but we saw fewer innovations this year. It wasn't a year where there were a lot of new product launches. What it was a year of catching up, of these new concepts that we've been talking about, software-defined automation, artificial intelligence. The past couple of years, there's products starting to come out now. There's these technologies that are being integrated, and they're enhancing these products. There's more and more things that are becoming concrete, even if there's not fantastically new products that were showed at the fair.
I agree.
For example, 3 years ago, we saw the first co-pilots that they appeared a half a year after the first of us ever tried using ChatGPT. It was an amazing turnaround. We saw co-pilots as add-on, as sidecars to existing engineering tools. But now we're starting to see AI enhancing other things like data analytics or predictive maintenance by using machine learning to help users save the trouble and the time of going through sifting through data. It's all done automatically to spot patterns, basically.
I mean, we use Copilot, so we recorded the podcast first at home, then use Copilot to script it and condense it further because it's our input, it's our ideas, but it's a great tool to speed up things. Speaking of speed up processes, Siemens talked about automating the automation. What does that mean?
You have to think about it. It sounds a bit awkward, Siemens. It's two words basically the same, but it's actually pretty compelling if you look at it. It's very simple. We have automation, but there are many processes in the generation of automation and in the operation and maintenance of it that can be automated. We don't need to do everything by hand and constantly repeating things we've done before. It's basically adding AI to enhance automation.
What I have observed is really mid-sized companies getting into AI more and more. So it seems to be easier and easier to use it, to implement it, to integrate it. Is there any specific observation that you had from the SPS?
All right, SPS is not a messaging show. It's more of a product show, but it is in Nuremberg, so it's technically Siemens' secret house fair.
Shh, don't.
They save hotel costs, let's put it that way. And so Siemens uses the opportunity to show a message, even if the others don't so much. And the message this year was it set a new goal that users can strive for using these two technologies. And I found it really interesting. I hadn't heard of this. It's called goal-driven workflows. And it sounds like something invented in some university somewhere, and now it's being implemented. And what it means basically, it's very simple, is you work backwards. You state the goal that you want to achieve. Let's say you want to increase factory output next month by 4%. So you type in the goal, and then the process works backwards and tells you how to redefine and reshape your processes in order to achieve that goal. And think of it like simultaneous equations. There's often more than one answer, more than one way to get to where you want to go. But the idea is that these processes have to be intelligent and flexible enough that they can be reconfigured on the fly in order to reach your goal. What I found interesting about the message was that Siemens said we can do this with two technologies. And by the way, we have them. One is called AI, and the other is called software-defined automation.
Software-defined. Two questions. One question, one comment.
Mm-hmm.
The comment is what you mentioned about that goal-driven. Something similar was mentioned at Namur.
Mm-hmm.
So they explained how in a project they were always keeping track of what they are doing, but not necessarily why they're doing things. So always keep track of the why as well. And then you mentioned software-defined automation, but that's a company, right?
It's a lot of things, Florian. It's let's get it out of the way. There's a company called Software-Defined Automation. It's a startup. It's based here in Munich. They do some really cool stuff. I'd like to say they do fleet management of automation assets. That's version control, documentation, all these things that have been neglected by PLC suppliers or haven't been done well across PLC brands in all these years. But software-defined automation was the general theme of the show this year. Everybody showed their version of the side of software-defined automation that they think is relevant to them and that they can focus on with their products.
But there's a lot of confusion. So everyone has their own definition of software-defined automation.
Mm-hmm.
So you need to write a paper.
In 1 week, you attended two different events
Yes.
in two different parts of Germany. I think you left our show in Nuremberg, and you took the train up to somewhere up in the upper left-hand corner to visit the Namur General Assembly. Can you tell us, first of all, what does Namur stand for? What is the organization?
So everyone knows words like Mittelstand or Kindergarten. So now it's another German word, and actually more, but So Namur stands for Normenarbeitsgemeinschaft für Mess- und Regeltechnik in der chemischen Industrie. So
Fascinating.
A very German organization with global impact. So founded in 1949 by Bayer, BASF, and Hüls, which is now Evonik. They have around 650 participants there, which is slightly less than our Orlando forum that we have in February. And I think they're best known for the Namur recommendation, the Namur Empfehlungen. And those are best practices, how certain things can be addressed. And they have impact far beyond the chemical industry. So they're used overall in the process automation space.
All right. Every year, a vendor sponsors the event, pays for everybody's dinner. Who is this year's sponsor?
This year it was Krone, the field instrumentation company from Germany. So, and they talked about open architecture and standardized communication for autonomous plants, which you need. Device and process diagnostic, including predictive maintenance with intelligent sensors, which is something that we write about for quite some time because we see that intelligence going down to the device level. Automated partial testing, monitoring for safety circuits for improved safety and availability. AI-based leak detection on pipeline management and some other things, and also, of course, sustainability. So it's interesting what I mentioned earlier about the Mittelstand, how they're bridging the gap, and everyone needs to find their own way. And Krone is clearly going into this AI intelligence integration and making it easy at the same time, making it easier for the users to use, maintain, and operate with their equipment. Very interesting.
In terms of digital transformation, what else did you observe about the process industries at the event?
It was really a lot about autonomous operations. So already last year, we had a case study from Covestro where they used one sort of autonomy on a very small part of their plant. But the chemical industry is doing that against the economic situation that I already described. They actually call that as a structural stress test. So the technology as well as the economic environment combined, creating that stress test. but they're really focusing on autonomous operations. And I talked with Thomas about that, and Thomas is, I don't know, at the Namur since forever and a day. And he explained that to me, and he says, well, look, the chemical industry is really, really focusing on their operators up to now to run the plant. They have, I don't know, Herbert. Herbert runs this part of the plant. He knows it in and out. They're really relying on these experienced operators. Now, they will fade out. So they may have a successor of Herbert, but not for everyone. So we have that brain drain, we have the demographical shift. So they need to work towards autonomous just to keep it running. So they really, that's a whole shift in the thinking of the industry. So what they are striving towards is autonomous operations and the lifecycle excellence. It's not just setting it up, but also the complete lifecycle, which is responsible for 80% of the cost. CapEx is not that big. And they speak about data-driven optimization, and they really want to reduce the manual interventions that they have to really optimize the complete life cycle.
What about specific new technologies? I'm thinking of all those three-letter abbreviations, the TLAs.
The TLAs, you mean NOA, Namur Open Architecture, AAS for Asset Administration Shell, and APL for Advanced.
For example.
Yeah. Well, you have all these technology. What's interesting that also in the backdrop of these structural stress test, when you talk to the end users at Namur, they say good is good enough. Sounds weird. We're still building the best mousetrap in the world often, but they are really now saying good is good enough. If that instrument, if that valve, whatever, it does the job, is good enough. So I focus on that more open architectures, which enables plug and play for field instrumentation. That was demonstrated very well, and I think I heard a few pennies drop when they had that in the big room. So all these TLAs, asset administration chain, Namur open architectures, and APL, they serve that goal towards more autonomy, reduced life cycle costs. And since a few years, I think APL is the hottest topic at Namur, also at other organizations in Germany. So, and actually the adoption is good, and it's surprisingly fast for the process industry. Well, skip for the process industry. For overall industry, the adoption of APL is rather fast. We sometimes heard that the hardware costs are still higher for any field instrument that has APL and compared to a standard instrument. But there was now presented a study from the University of Cologne that showed that the increased hardware costs are basically completely offset by the reduced installation and engineering costs. So what you pay a bit more in hardware, but you serve the engineering time. And remember, we don't have the engineers, so that's what you want to save.
I would expect that. I would hope that it's a new technology is going to cost a little more, but especially process users think in the long term. They're thinking of amortizing the costs over 20 or 30 years.
But the process user is not building the plant. You have to also convince the EPC who actually builds the system, and if he is having tremendous more spendings to do APL, he won't do it. And that was shown, the whole money is basically completely offset, and it's already offset. In BBLs, we don't have a lot of products, so as soon as the volumes grow across the multiple vendors that offer APL already today, then also the costs will drop down. And it reminds me of a discussion we had many years ago about IO-Link. And they're also, because they standardized the silicon and that enabled a lot of the mid-sized players to reduce the costs for the more advanced sensing, so proximity sensors, but also photoelectric sensors. So they were able to reduce the cost because they were able to use the economies of scale in the silicon. And we expect something similar to happen in APL.
All right. Let's go to a two-letter abbreviation.
Oh.
And this is my last question for today. What about AI? That must have been a topic as well at Namur this year.
Yes. So autonomous, you can't do that without AI. So AI enables you to achieve autonomy in a setting that is not 100% predefined. So last year we had this Covestro case study. Also Covestro this year presented something about an autonomous plant. So it's moving forward. When also we talked with others and I said, yes, we're using AI, we want to use it, we want to go towards autonomy, but we want to remain in the driver's seat. So unlike some case studies we had on our forums in Sitges this year and last year, where people really talked about closed loop AI control, they talk about open loop. And it basically has to do something with mindset. It has to do something with consequences. So if you get something wrong on the machine level in a discrete industry, you may ruin the machine. If you get something wrong in Leverkusen, you may blow up a whole city. So the consequences are really, really big. What I found very interesting is there was one session about AI for MTP, so for modular type package. So these modular...
AI in MTP?
AI in MTP.
Tell us about that.
Yeah, but the interesting thing about MTP is because it already shrinks down the complexity to a certain task. So being it the physical module, a container, or a virtual module, which can be anything in the plant, because you can use MTP in brownfield later on, but it shrinks down the complexity, and they are exploring. So do you need AI to simply tell the operator what is the pressure, the temperature, and the level? No, you don't. Do you need AI for the most complicated card? You cannot do that. You don't have the data. So they're exploring where the sweet spot of AI is, similar to what we basically tell people as well. So you need to find the sweet spot between manual, traditional automation, and then how AI fits best in the middle.
Interesting. You just gave me a new trend to write about in the new MTP study.
No, you first have to do the SDA first. First SDA writing, then the other one.
Yeah. All right. Florian, thanks for for joining me for the talk today. We're going to switch gears, maybe change clothes and put on a new pot of coffee. We hope you stay tuned for our expert talk on cloud and edge architectures.
All right. Thank you, David. I'm looking forward to the expert talks. Thank you, everyone, for joining us for this episode. Please like and subscribe. Help us grow the channel. You'll get all the latest information. And the link to all further reports and details, we're all linked that in the show notes. Thank you. I'm here with David, a freshly brewed cup of coffee, and we're here to talk about edge and cloud on the shop floor. So, David, we are following this IT-OT convergence for a while now at ARC, and it basically means that in the OT world, we also use tools and technology which are common in the commercial world. But the transition is so slow. And so it's like it has the speed of a snail. It's step by step. It's just everyone is super careful. In my honest opinion, we're not getting ahead as quickly as we should.
It's okay. It takes time because we're using machines that have a life cycle of 5 to 15 years. And as long as the machine is running, we're not going to change anything. We don't have a window to adopt new technologies until that machine has run its course and is replaced by a new process.
So so we have this huge, old, established, sounds better, installed base, and now we're talking virtualization. Where are we with this?
Virtualization is as a key technology that we're borrowing from the commercial world that has been using it for for 20, 25 years. Virtualization is just taking a piece of software and sticking it into a container, or we can call it a virtual machine. That the virtual machine contains the software, and then it contains the operating system that that software needs to have, whether it's the latest operating system or a legacy operating system from years and years ago. But it containerizes it, protects it, and allows you to move that virtual machine around and from host to host, or to put several together on a single machine. And why is that good? Well, in the manufacturing world, it allows me to clean up software that is scattered all over my shop floor. So for years, I've had machines delivered, and each machine has a controller, has a PLC on it, but it also has some additional software that's written in C++ or from Fortran 77, whatever. But it's all disparate software, and it has to be maintained. The software has to be maintained, but also the hardware that it runs on and the operating system it runs on have to be updated, or I might have to have a new chipset or memory chipset to be replaced. And the problem is that this sort of hardware was never meant for industrial environments. It wasn't meant to live as long as our life cycles live, and it wasn't meant for the rough conditions that we often encounter on the shop floor.
Actually, it sounds quite complicated, like open heart surgery on an access plan. So what is driving all that? Is only like getting rid of little gray boxes, or
it's cleaning up, getting rid of the hardware that you don't want to have to maintain anymore.
Okay.
It's reducing the amount of hardware to only new hardware that I have control over, because it's my Dell or my HP server that has the capacity of 10 old industrial PCs.
All right. And you mentioned the software, so it's a bit scary that our machines run with software that was coded when someone was playing Prince of Persia with floppy disks.
It's scary as hell in some cases. You might have a machine that was delivered 15 years ago. If you have a problem with the software, let's say you want to make a change to the software to make a minor conversion or add a little bit more capacity, that machine builder might not be in business anymore. Or maybe they're in business, but the guy who wrote the software, He's retired 6 years ago. He's playing golf today, but he doesn't remember what he did anyways. So it's a way of extending the life of your investment in legacy software back then to squeeze even more life out of it today, and to ensure, most importantly, to ensure the continuous operation of your equipment.
Okay, so what you mentioned so far is really the user perspective. So maintaining hardware, getting rid of little gray boxes, and also maintaining software. And of course, we talk a lot about the installed base, but what about new stuff? Why should a machine builder that ships a new machine to a greenfield plant, why should he do it? Are they actually doing it?
First of all, the machine builder shouldn't do anything unless the customer asks for it. So if the customer has a software-defined environment, a software-defined factory, where he says, like Audi is a good example with their EC4P initiative. They said they'd like to say that we used to buy a new function in a box. We'd get it delivered in a gray box. We'd put it on the machine, and it would run. In the future, all we want is that function delivered in software. We'll decide where the software runs, where we put it. That's the new mantra for the software-defined factory.
All right.
So you asked about the machine builder, though.
Yeah.
But the machine builder needs to have a plan for both scenarios.
And
So
are they already doing? I mean, it sounds super.
some machine builders
Sci-fi.
take their non-time critical software. Let's make a difference here. Non-time critical software. This is operational software, maintenance management stuff, line management. They deliver it on an IPC, and some customers want that. But starting now, there are customers saying, "Don't send us the box again. Just send us the software. We've got the box here, and we're going to put it next to other software because we need to start maintaining software like the IT people we've become."
Do you have any examples? I mean, it's a concept, or is it
It's being done. It's being done today.
Name und Dienstgrad, name and address.
Cronus in the packaging and bottling industry, Cronus, KHS, SIG Combi Block, they all have dabbled in virtualization, in delivering virtualized versions. Tetra Pak, we did a project some years ago with Tetra Pak in Sweden, and they said we do virtualization, but it's not a standard thing. But it's becoming a standard thing because it's easier to maintain for non-time critical software.
Yeah. Okay, David. So I have one important question here, and it's a question you can probably fill 23 podcasts with. Any idea what that question is? So, what is real time?
Oh, that's an easy question. For most machines, real time is anything around 5 or 10 milliseconds. Below that, faster than that, you need for hard motion control. And anything above that covers, I would say, 80% of the other applications that don't need hard real time.
Okay.
Yeah.
All right. So we talked now about real time. We talked about virtualization. What we haven't really discussed is like the whole edge cloud thing. Can you give me a practical example from the shop floor where all these things come together and where it's put in use?
They all come together right here in Bavaria at a company called Audi. Audi is absolutely leading the pack in terms of inventing what edge and cloud should be for, in this case, an automobile manufacturer. Audi has had this initiative for over 5 years now called EC4P, that's Edge Cloud for Production. And in the first phase of it, they consolidated hardware on the floor, put all the software into virtual machines on servers, and did the general cleanup. The most recent step has been focusing on the PLC. The PLC has always been the hardware PLC. Now they virtualized the PLC and put that on a server as well.
Right. No safety, right?
You know what? I hate to I hate to blow your religion, but now we're even doing safety in virtual PLCs. It seems crazy.
The tilt switch, and then does you have the physical switch, and then it goes to.
It's interpreted locally.
Okay.
But it's interpreted actually by the virtual PLC. In this case, you're going to flip out when I tell you how far away the PLC is. You don't even have to guess. It's 8 kilometers. That's the answer. In this case, they have a data center where their servers are running all the virtualized software, and even the virtualized PLC and the virtualized safety PLC are running in this data center. And there's a long company-owned cable. It's not any sort of public thing that goes to the different plants. And the one that runs the virtual PLCs is 8 kilometers away. That's 5 miles. And it works, and they're able to maintain on the network side a jitter of less than 100 microseconds.
Right. So,
Seems crazy.
In this case, on the machine, you have a few edge devices directly connecting to the internet, the company-owned.
Exactly. Yeah.
But the whole thing is basically running in a private cloud, in an on-premise cloud. Completely virtualized.
Yeah. Most companies, when they speak about cloud, they're talking about an on-premise server cloud. It's the same thing. It's the computing box that's in the same building. In the case of Audi, they've taken one step and they put it down the road 8 kilometers. That's their thing. But I think most manufacturers will interpret a cloud as being a private cloud that is nearby at least.
Okay, so then the PLC market is like going down the bin.
Not at all. The PLC market is bulletproof. It's about $13 billion, according to my own recent research. The virtual market hasn't even scratched the surface yet.
So the technology is there. We can do it. The use cases and everything, but we're just in the early phase of the adoption.
Yeah, you can buy these things, but actually nobody buys a virtual PLC. We rent them for an annual fee of about 1,000 euros per PLC. That market is just starting, and it's going to take some time before there's any uptake. Every company has to test them. They have to do a test cell. They have to let that run for a year or two. Audi has them in production in parallel with the old PLC. So if anything goes wrong, and nothing has gone wrong so far, but they can easily switch to the old S7s, no problem.
So they have the fallback option.
Yeah, and it's a new culture. It's a new religion that people are getting used to, and these new cultural transitions take the typical 5 to 8 year period before there's any sort of uptake. So no rush to go out and invest in virtual PLC markets right now.
All right. Thank you so much, David. Great insight. And we need to do one on the virtualized DCS as well.
Yeah, we'll get to that. That's coming as well. Yeah. Thanks, Florian.
Hello, this is Florian Güldner of the ARC Advisory Group. We cannot take your call right now because we are all busy on the trade show. Thanks for calling.
Jaco, it's great to see you again here in Namur. Just want to hear your thoughts about Edge. What's going on? What are the challenges? And how are you guys overcoming this? What do you think about that?
Yeah, I think Edge is one of the technologies in the process control space. Certainly, what we now call OT, that is bringing a lot of promise, a lot of openness to systems that are closed nowadays, proprietary. I think the Edge, at least that's how I see Edge, should be a standardized way of inserting new technology or provide the capability to replace existing technology, to open up the OT stack from the bottom up. So yeah, I think it has a big promise and certainly a lot of value if we can make it work.
What are the major challenges that you see there?
Major challenges is that it's not standardized. So the standardization of the Edge is something that is kind of holding us back. Obviously, suppliers are creating their own Edge, but still that's in the proprietary environment, which is great, but it's not always what the end users need. So open Edge is certainly something we're striving for. And I think as an industry, we would benefit enormously. So,
How can we move forward? How can we push solution providers on this?
well, I think the way forward is, and I'm a bit biased because I've been heading the OPAF initiative, but I think there's a number of steps you have to take. First, you have to define the standard. I think with OPAF, we've defined a standard that really stands, and I think it stands out. That's one thing, but then people have to start to get the experience. So I think building test beds and doing initial pilot projects, I think that's essential. Sharing that information after that is even more essential. So and then create open platforms where we can experiment, where people can experiment, where suppliers can experiment, and by doing that, create an ecosystem that is truly open. So, I think everyone has their strengths and weaknesses. If everyone can bring their strengths and leave the weaknesses at home, probably where you're weak, someone else has its strength. So it makes a lot of additional value altogether. And I think that's what we should do. So it's a staggered process. And I think we're kind of halfway through, but now it depends on how we are going to take it and use it. And that's really important.
Thank you very much.
Okay, you're welcome. It's a pleasure.
Industry Talks by ARC Advisory Group.